Today we are going to go over 3-4 concavity and second derivative test and how to sketch the curve. So the test of concavity. Let f be a function. The second derivative exists. In this case, if the second derivative is positive, we call it concave up. If its second derivative is negative, concave down. And the point of inflection. How do we find the point of inflection? So there are two cases. So we take the second derivative is if the second derivative equals 0, or the second derivative doesn't exist. We call this point is point of inflection. So remember, there are two cases similar to the critical points. The second derivative test. We learned first derivative test for relative max and relative min after we do the sign analysis. For the second derivative test, what we do is first we calculate the first derivative, we set equal to 0, and then this gives us the critical point. Then we are going to check at the critical point. If the second derivative is positive, it gives us a relative minimum. If the second derivative is negative, it gives us a relative maximum. So first we find the critical point. Second, we do the sign at that point for the second derivative. So if the second derivative equals 0, we cannot apply the test. So before I go over some examples, I want to go over the two very important type of points we learned in this class. First, critical points. We have two cases. First derivative equals 0, or first derivative doesn't exist. Inflection points, also two cases. Second derivative equals 0, or second derivative doesn't exist. However, first, before you consider the points as critical or inflection points, you have to check if that point is defined. If the function is not defined at that point, we don't consider that point as a critical point or inflection point. Let's see some examples. So if you look at this picture, so on the test, you have to be very, very careful what is given, f of x or f derivative. So if you look at example 1, fx is given, so the inflection point, concave up to concave down, 2 and 5 give us two inflection points. Absolute maximum value, y equals 3. X equals 1, that's a minimum value, which is local or relative minimum. Because the interval is closed, we do have absolute max or absolute min. So absolute max is at 3 and absolute minimum is at 7. So the 1.8 or 0.1 is just an approximation. Let's look at example 2. How do we solve all the extreme values, increasing, decreasing interval, and also inflection points and concavity? So first we take the derivative, and x cannot be 2 over 3 in this case. So when we take the derivative, we simplify it. Just be careful. I factor the numerator. This is what I have. I set equal to 0, give me 2 critical points. Okay, however, when I draw the number line, I put the critical points here, and also I put the point 2 over 3 here, because 2 over 3 is not defined. So then I do the sign analysis. I check the derivative, first derivative. So gave me increasing and decreasing interval. And relative max and relative min. So from increasing to decreasing gave me maximum, decreasing to increasing gave me minimum. So for the inflection points and the concavity, we take the second derivative. This one and the power, we have the fourth power in the denominator. And then I simplify the problem. So the second derivative equals 0. There's no solution here. That means we don't have any inflection point. However, when we sketch the number line, we also need to include the point 2 over 3 there. because that's where the function is not defined. So based on the sign chart, concave down from negative infinity to 2 over 3, concave up from 3 over 2 to infinity. And if you look at the sign for second derivative change from negative to positive. However, it's not an inflection point because the function is not defined there. For example 3, you can follow the same process and see the final answer here. So curve sketching. So we are going to use what we learned before to sketch the curve of any given functions. So what information we need? X, Y intercepts, if there are any holes or vertical horizontal asymptotes. And sometimes we also have slant asymptotes, but most likely horizontal and vertical asymptote, those are more popular. This, we don't have to worry about this one. And also because we learned the derivative now, we are going to include all the critical points, maximum minimum points, increasing decreasing interval, and the concavity into our graph. For example 1, given this function, so first we take the derivative and the second derivative. So from the original function, we should be able to get xy intercept, vertical asymptote, horizontal asymptote. And from the first derivative, we should get increasing decreasing interval. We find the critical points first. Increasing decreasing interval, max or minimum value. From the second derivative, we find inflection points, concave up, concave down. Okay, those are the sign chart for each one. Based on this all information, we can sketch the graph like this and label all the important points. Minimum value, inflection points, max, intersection. You can try the next 2 examples yourself. I put my solutions here. You can also check the graph with your graphing calculator.